Hello students, all of you welcome to Future Doctor NEET Academy. Today I am going to give 7 problems in chemical equilibrium chapter. This is one of the chapter in 11th standard. This is also problem oriented topic. So compulsory will be getting at least 1 or 2 questions compulsory. Okay. Now I am going to give some 7 questions today. So you just go through the question. Okay. So this also we have formula is there. Before I am giving the solution, you please ready for that. Understood? Then only when I teach, I used to understand. You must know the topic. I already told you. You must know the topics. You must know the concept. You must know the formula. Okay. So this is all you must know. Okay. Before I am taking class, then only you can use to watch all the use to understand the problem. Understood? Now I am going to give the 7 questions to you. Okay. Just see the question. See that in a chemical equilibrium, the rate constant for the forward reaction is 2.5 into 10 power 2 and equilibrium constant is 50. Rate constant for the reverse reaction they are asking. Okay, the rate constant for the reverse reaction is asking. There is also one formula for that. If you use that formula, you can use to solve the sums. Understood? Okay, this is the first question. See the next one. For the formation of 2 moles of SO3 in gaseous state from SO2 and O2, the equilibrium constant is K1. The equilibrium constant for the dissociation of 1 mole of SO3 into SO2 and O2. Okay, so this only they are asking. So we have to compare. We have dissociation equilibrium, we have association equilibrium. These 2 terms, if we compare, means we can able to find out the answers. Understood? First of all, you should know how to write the equilibrium constant for any equilibrium reactions. So if you know this, you can use to solve the sums. Okay, the equilibrium A 2A gives 2B and C2 in gaseous state. The equilibrium concentration of A, B and C2 at 400 Kelvin are 1 into 10 power minus 4, 2 into 10 power minus 3 molarity and 1.5 into 10 power minus 4 molarity respectively. The value of Kc. They are asking to find out only Kc. Kc is nothing but equilibrium constant in terms of concentration. That's called Kc. We have Kp is also there. Okay. That is called partial pressure. So they are asking to find out only the Kc value. The option is the 4 option we have given 0.06, 0.09, C option is 0.062, D option is 3 into 10 power minus 2. Okay. Now see the next one. Fourth question. The relation between Kp and Kc for the following reaction is N2 plus 3H2 gives 2NH3. This is one of the equilibrium reaction. In this equilibrium reaction, they are asking to find out only relation between Kp and Kc. Okay. What's the relation between Kp and Kc? They are asking. Option A, Kp is greater than Kc. Option B, Kp is less than Kc. Option C, Kp is equal to Kc. Option D, Kp is equal to 1 by Kc. Okay. So you have to find out the del and G value. Then you must know the relation between Kp and Kc. If you know this, you can use to solve the sum. Understood? Okay. This is a very important one. We have only few formulas. So one of the important relation between Kp and Kc, we have one formula is there. If you know the formula, we can use to solve the sums. Understood? Now see the next one. The value of Kc for the following reaction at 717 Kelvin is 48. One of the equilibrium reaction is given H2 plus I2 gives 2Hi. Okay. At a particular instant, the concentration of H2, I2 and Hi are, all the concentration is given. H2 is what? 0.2. I2 is what? 0.2. Hi is what? 0.6 mole per liter respectively. Okay. All the concentration is given. By using this, we have to predict whether the reaction is or whether which direction the reaction is proceed, forward direction or reverse direction or equilibrium reaction or none of this. Okay. So if you want to predict the direction of reaction, we have the Kc value. Okay. From this we can able to find out. Okay. Understood? Okay. Depends upon the Kc value, depends upon the Q value. Okay. When you relate Kc and QC, we can use to find out. Okay. That condition you must know. Okay. Sixth one. 2NO2 gives N2O4 plus 60.0 kilojoule. The increase in temperature, it may be favor the formation of N2O4 or second option favor the decomposition of N2O4. C option does not affect the equilibrium or D stops the process. Okay. So in this equilibrium reaction, if you increase the temperature, what happens they are asking. Okay. It goes on forward or it goes on backward or does not alter or stops the process. Okay. So increase, we have factors are there. If you follow the Lake-Chatterjee principle, you can able to answer this question. Understood? Are you following? Okay. The temperature term and pressure term is very, very important. If you know these two terms, it is present in Lake-Chatterjee principle. Okay. You can easily solve this sum. Okay. Seventh question, N2 plus 3H2 gives 2NH3. Kc is given. Kc value is given 0.50 at 673 Kelvin. Okay. The constant, equilibrium constant for reverse reaction. They are asking equilibrium constant for reverse reaction. Understood? So the value is given. Okay. Option A 1, option B 2, option C 3, option D 4. Okay. So we have one relation of forward reaction and reverse reaction. That relation, if you know, means you can use to solve the sums. Understood? Okay. You try. First you go through the topic, then you must know the formula. What are the formula behind in this topic? This now, if you know, means I put only very, very simple sum, very easy sum. Okay. The next first session, all the lessons we are giving 7 questions in the first session. The second session we will give some. First session we are giving very easy question. Second session will be given somewhat medium. We are going to increase the content. Okay, content based question. Okay. So the first session very, very easy, very dead easy questions. Okay. So anyhow, if you know the concept and formula, then only you can able to answer this question. Okay, very simple question I selected. Okay. You try before start the class. Okay. Thank you, students.